Here's a beautiful example courtesy of Pearson's Mastering Physics website. A contraption that has two pulleys connected as one. One pulley has the mass of 6 kilograms. It's the smaller pulley right here with a radius of 5 centimeters and a 4 kilogram object hanging from it. Another pulley of 10 centimeter radius and double the mass, 12 kilogram mass, is attached to the first one, and there's a 2.5 kilogram object that is hanging from it. So here are the mistakes that can be made, and I would like to caution you from them. The first mistake that you can make is you can just say 4 times 9.8 would be equal to the force of tension on the right, and then 2.5 times 9.8 would be equal to tension on the left. No, no, no. Because if your pulleys are rotating with acceleration, your objects are moving with acceleration. And in that case, tensions and the gravities are not the same. That's the first mistake. Another mistake that you can make, you can assume 4 times 9.8 minus tension on the right should be equals to 4 times acceleration, and then tension on the left minus 2.5 times 9.8 should be equal to 2.5 times acceleration. Then add these two, assuming that these two accelerations are the same. They are not. Those are tangential accelerations. What will be equal for them would be the angular accelerations. Angular acceleration, yes, but these two are different. So that's the second mistake. So let's solve it correctly. Let's accelerate it that way. Let's say it's actually counterintuitively going to accelerate this way. So I'm going to start with the 2.5. 2.5 times 9.8 minus tension on the left should be equal to 2.5 alpha times 0.1. Then tension on the right minus 4 times 9.8 should be equal to 4 times alpha times 0.05. Let's consolidate that. So 24.5 minus tension on the left should be equal to 0.25 alpha, and then 39.2, and then tension on the right minus 39.2 should be equal to 0.2 alpha. From these two equations, I'm going to express TL to be equal to 24.5 minus 0.25 alpha, and T on the right to be equals to 39.2 plus 0.2 alpha. Now let's use our Newton's second law for the system of pulleys. It should be the difference, and so again I assume tension on the left times 0.1 minus tension on the right times 0.05 times 0.05 squared over 2 plus 12 times 0.1 squared over 2, which is 0.0675 kilograms times meters squared. And then I'm just going to go and plug everything in. 0.0675 times alpha should be equal. Instead of TL, I'm going to use 0.1 times 24.5 minus 0.25 alpha, and then minus, and TR is multiplied by 0.05, and then TR itself is 39.2 minus 0.2 alpha. Now the sad part is physics was over a long time ago. We're just corralling our algebra skills. Moving your decimal to 45 minus 0.025 alpha minus, now 0.05 minus 1.96, which is these two, and then minus 0.01 alpha. Okay, where's my equal sign? Right here. Then I have my 245 minus 1.96 is the only constant, and then these two puppies go with the plus to the left. 0.1025 alpha should be equal to 0.49, and then alpha from there is 0.49 over 0.1025, which is 4.78, and that's rads per second squared. So when I translate that into accelerations of my objects that are hanging on the pulleys themselves, so the acceleration of the 4 kilogram object is going to be 478 multiplied by 0.05, I get let's round it, 0.24 meters per second squared for the 4 kilograms, and it's going up. And then the same 4.78 times 0.1, obviously it's going to be 0.48 meters per second squared. That's the 2.5 kilograms, and it's going downward. So see how their accelerations are actually different. Now, if we wanted to find force of tensions, for example, to double check that we're doing it right. So then the tension on the right, the one that supports the 4 kilogram object, should be the sum of 4 times 9.8 plus 0.24, which is 40.16 newtons. And then T on the left should be 2.5, and that will be 9.8 minus 0.48, 23.3 newtons. Now if I do 40/16 times 0.05, that's 2.008 newtons times meters, and that's the clockwise torque. And then 23.3 times 0.1, that's obviously 2.33 newtons times meters, and that is counterclockwise. So now if we subtract and find our net torque amounts to 0.3, about 0.322. And then remember, net torque being I times alpha is 0.324. That's just rounding. So there we go. Lots of algebra. The acceleration of this whole contraption, the angular acceleration of the pulleys, should be 4.8 radians per second squared counterclockwise. Boom, boom. That's the answer.